Hello everyone, welcome. So today I am going to answer questions that you may have over the review. And those of you who are watching the recording, you can't ask questions because you're just watching a recording, right? But you can definitely see what kind of questions others have. So the reviews that you're looking at are under announcements. If you go to your My Stat Lab course under announcements, I have several reviews here that I talked about the other day. And we have review 1, review 2, and review 3. I wanted you to try review 1 and bring your questions today. But of course, if you happen to have questions on some of the other reviews, we can do that as well. So this semester, I'm doing things a little different. Your final is going to be over chapters 7 through 11. The final exam you're taking is the second part of the course. We've already had a midterm over the first part of the class. So now you're going to have another exam over the second part of the class. So chapters 7 through 11. Now only of those who are attending live can ask questions, but if you're watching the recording, just remember that all of my reviews, you have keys for all of the reviews. All right, so you have keys for all of the reviews. All right, so there are a couple of questions now. All right, so as students ask questions, I'm going to go ahead and I'm just going back to make sure I get all those. Yes, okay, so far one question. So on the final review, which is this one up here, and by the way, if you notice, that's chapters 1 through 11. So remember, this semester your final is going to be only chapters 7 through 11. So if you have any material from chapters 1 through 6, you don't have to worry about that. I've already tested you over that on the midterm. Okay, so this is review number 2, questions 9 to 12. All right, so far that's the first question we have from review number 2, questions 9 through 12. So we're looking at review number 2. Okay, so on here, you're back on my Stat Lab. So review number 2, I'm going to click on that. And that's what it looks like. And so we're looking for questions 9 through 12. All right, so does that seem okay? 9 through 12, they're not all from the same problem. It looks like 9 and 10 are from one question, and 11 and 12 are from a different question. So that's review 2, questions 9 through 12. Does that look right? Okay, review number 1. Okay, so review number 1. Okay, so it's supposed to be review number 1, questions 9 through 12. Okay. So that's what review number 1 looks like. And again, 9 through 12. Okay, so that's all from one problem. That makes sense. All right, so we're looking at review number 1, questions 9 through 12. All right, so what I'm going to do is I am going to take a snapshot of that, and it moves it over to the whiteboard, and then we'll look at it there. Okay, now let's see if I can make it bigger. A little bigger. Let's try that again. All right, maybe a little better than before. All right, but just remember you do have these available. All right, so I went to my stat lab and it's review number 1. That's the one I opened up. And we're going to go ahead and look at questions 9 through 12. All right, so as I'm doing this, some of everyone else, if you have any other questions, let me know. You can just type it at the bottom, okay? All right, so, and of course this only goes for those who are in attendance live, not for those who are watching the recorded lecture. Okay, so for this question, it says a random sample of 100 babies is obtained, and the mean head circumference is found to be 40.6 centimeters. Okay, so from that random sample, we have a measurement. And that measurement is the mean head circumference. So n is equal to 100. From that random sample, we have a mean of 40.6. Now it says, assume that the population standard deviation is known. So we know what sigma is according to this. Sigma is 1.6. So sigma here is given. Use a 0.05 significance level to test the claim that the mean head circumference is equal to 40 centimeters. All right, so that's our claim, that the mean head circumference is equal to 40. So which parameter is being tested here? We're talking about the mean. Where does the claim go? The claim has the condition of equality, right? So it must go in the null because only the null has the condition of equality. And then 7, we have to write out the null hypothesis. So the mean equals 40. And that means that in the alternate hypothesis, the mean does not equal 40. So the claim, again, happens to be in the null because that's how it's stated in the problem. It says to test the claim that the mean head circumference is equal to 40 centimeters. So that's why I put the claim in the null. So the claim has a statement about equality. So now we have to decide, so the questions was questions 9 to 12. So the question you had starts right here, but I had to set it up because I needed to know what the problem was about. Okay, so as far as the test statistic, we have several formulas to choose from. So what I want to do is I want to show you where those formulas are. Okay, so if you go back to announcements, this is what you are allowed to use for your final exam. You're allowed to use the formula card, and I have an editable format in a PDF format. I'm going to open up the PDF format, and then I also have tables attached here. It's under announcements. Okay, so I'm going to open up. These are just formulas from chapters 7 through 11. Okay, so the first thing you have to do is you have to decide where this problem is coming from so that you know where to look. That way you know which set of formulas you have to look at. So this is hypothesis testing, and then chapter 8, that's where we talked about hypothesis testing. And so the question here is this one sample or 2 samples? Or 1 population or 2 populations? So we know it's hypothesis testing, so that's chapter 8. Chapter 9, though, is also hypothesis testing with 2 populations, right? 2 samples. Yeah, this one we only have 1 sample size, n equals 100, so definitely from chapter 8. So hopefully you're in the right chapter so you can look at the right formulas. Now notice that we're testing the mean and sigma is known. So we're testing the mean and sigma is known. So if I go back, we're testing the mean and sigma is known. So chapter 8. Okay, so these are your test statistic formulas for chapter 8. We have two formulas for the mean. We have two formulas for the mean. And it all depends on whether or not you know sigma. And so the two formulas you have for the mean and the one you use depends on whether or not you know sigma. So do you remember, did we know sigma here? All right, so then we have to use the first one. So it's the z-test. So we're going to go ahead and write down the formula and then continue with that. All right, so keep in mind this formula. So let me answer the other question that was asked. What can you use for your final? So this is the formula page you can use. It has chapters 7 through 11. All right, so this is okay. You can use this. When you print it out, well, I was in my class, I give this, it's just one page, double-sided. So this is what you're allowed to use. You can write more formulas on it if you need to, but not on the back, just on the front. All right, so you are allowed to use or to write down formulas on here. If I've left out any formulas or if I've left out anything that would be useful for you, you can write it out. But you cannot have two sides. I don't know if that makes sense. So if you print this out, it's going to be one page double-sided. Now this is just there for a reference. You don't have to use it. It's just that I already had this made up and I just edited it and I condensed all the formulas. So I will have some extra copies at the final. So if you bring something that you're not allowed to use, then I will exchange it for what you are allowed to use. So an alternative to this is that you just have one page of paper and you write your own notes in the front and in the back. One page of notes with formulas or whatever you think you need. That would be the alternative if you did not want to use this page of formulas. Does that make sense? Okay. So if you come in to the final with 2 pages of paper, these 2 pages, and you're writing on both front and back, you're not going to be able to use that. So remember, it's just this, what you have here. If you end up printing this out, and you can only write in the front. Or you can just decide to have 1 page of paper and then put your own formulas on the front and back. Okay, so let's go back to the formula we said we were going to use. We talked about the z-test. It's a z-test, right? So mu. And then our test statistic, I'm just going to copy it down. So let me see if I could move that over so I don't actually have to go back. There we go. Okay, so this is the test statistic I'm going to use. All right, so z equals, and then I have x bar minus the mean divided by the standard deviation over the square root of n. All the information I need is already there up on the top. So the sample mean okay, so someone's mic is on. Someone's mic is on, so you want to make sure that you turn it off because we're hearing some background noise. I can disable everyone's mic, but if I do that, the recording may not come out the way that I want to. Okay. All right, so I see that there's another question there, and I'll answer it as soon as I'm done with this one. Okay, so our sample mean, this is the sample mean that's coming from the 100 babies, 40.6, minus the mu, the mean that's in the null hypothesis, that's 40. So remember, when we work with the test statistic, it's always under the assumption that the null hypothesis is true. And then that's over the standard deviation. The standard deviation is the one that was given to us as the population standard deviation, divided by the square root of n, which is 100. So you have the numerator, and you have your denominator. Now you're only going to use this test statistic if you're testing the mean, and if you know sigma, which is the population standard deviation. Now this is not very realistic that we would know what's happening in our population. Usually we wouldn't know what sigma is. But if you do, this is the test statistic you would use. So if you go ahead and type that into your calculator, you should get your test statistic, and because it is a z, you would round it to 2 places after the decimal. All right, so what do you get if you put that in your calculator? All right, 3.75. Good. Okay, so 3.75. Now it's asking you for the critical value. So this is then the traditional method. The critical value is part of the traditional method of hypothesis testing. So the table that you would use is table A2. So you see how you're looking at Z? So then you're looking at table A2 for your critical value. All right, so your test statistic is a Z, so then table A2 for your critical value. And remember, critical value can come from a left-tail test, a right-tail test, or a two-tail test. What kind of test do you think this is? Is it a left, a right, or a two-tail test? All right, and we know because of the alternate hypothesis, right? So you're going to go to the alternate hypothesis to determine that. So not equal to, so two-tail tests. All right, and alpha in the traditional hypothesis test, alpha is the area in the tail. And alpha is usually given to you in the problem, but if it's not, then you're going to use 0.05. So in this case, alpha is 0.05. Now I have two tails, so I'm going to have to divide by 2 to get the area in each tail. So remember, if you have 2 tails, you always have to divide alpha by 2. 0.025. Okay, so ready to go to table A2. You are going to look up the area of 0.0250 if that helps you. Remember that the area is the middle of the table. All right, so let me take you back to the table A2. That's what I have on my screen right now. So I'm finding the left critical value first. So that left critical value is probably going to be negative if it's on the left of 0. So I'm looking for the area of 0.0250. The area, when you're using table A2, is in the middle. It's in the body of your table. All these are areas. So remember, 0.025. So I just happened to be lucky today, and I found it. It's right there. 0.025. 0.0250. That is the area. It just happens to be the area to the left of the Z critical value that I'm looking for. So you're going to go to the left, and I see a negative 1.9, and then you're going to go to the top and look for the value that matches up to the area of 0.0250, and on the top it's 0.06. So you're looking at negative 1.96. So your critical value is negative 1.96. And again, because that's what matches up to the area of 0.0250. All right, so I'm going to write here negative 1.96, and over here it's positive 1.96. So negative 1.96 and positive 1.96. Now the test statistic gets compared to the critical value. So if the test statistic lies in the shaded region, that means you're going to reject the null hypothesis. So look at your test statistic. Does it lie in the shaded region? Yes, definitely in the shaded region. It's greater than 1.96. So that means you're going to reject the null hypothesis. So we're going to reject the null hypothesis. So that means I'm going to go up here. I can cross it out. I reject the null hypothesis. So there's sufficient evidence to warrant rejection of the claim. So the alternate is what the data supports in this case. What's in the alternate hypothesis? Okay, now I'm going to skip the p-value for right now just so that I can come up with the conclusion. Remember that the conclusion you're following are the conclusions that I provided on that table. And I'm finding them for you. There they are. Okay, so I'm going to switch you over so you can see what I'm looking at. And so these are the wording of your final conclusion. This is the wording of your final conclusion. So this being the wording of your final conclusion, the first question says, does the original claim contain the condition of equality? So I think equality was in the claim, so that's yes. Do you reject the null hypothesis? That was also a yes, right? So there is sufficient evidence to warrant rejection of the claim. So that's your conclusion. So you just follow this this diagram that has the wording of your final conclusion. And on the announcements page of my Stat Lab, I went ahead and I put this under the final exam information. I put that table there in case you've lost yours or want a new table. All right, so that is what my conclusion is. So you go down here and choose the one that's the correct one. Now I think that I think it's C, right? There is sufficient evidence to warrant rejection of the claim that the mean head circumference is equal to 40. Looks like that's the closest one. Yes, that's exactly what it says. Okay, so what I just did is that's a traditional method of hypothesis testing. I compared the test statistic with the critical value. In order to get the critical value, I needed to use table A2. So when you're using the traditional method of hypothesis testing, alpha is the area in the tails. Here we happen to have 2 tails, so that's why I had to divide alpha by 2. You only divide alpha by 2 if you have 2 tails. Now, with the p-value method, then you're just comparing your p-value to alpha to see if you reject the null hypothesis. So if you remember, when we're looking at our formulas for Chapter 8, and when we decided to use, here's an arrow that I'm trying to draw, and when I use this test statistic, that's tied up to the z-test. So if you do the z-test, that's going to give you your p-value. So we found p-values many ways. We found p-values by hand, which we had the table to help us out. And then we also found the p-values on the calculator. So we had commands. We had like the z-test, the t-test, the one-prop z-test. There are other ways we found p-values. When we didn't have enough information from our sample, but we were only given the test statistic and the setup for the null, we had these other commands here. It was the chi-squared CDF and the t-CDF. These were other ways of finding p-values. All right, so for right now, I am going to remind you of how we did these by hand. So I'm going to go back to that table I was showing you. And then I'm going to show you how to do this on the calculator. So this is how you find p-values. So right now on the whiteboard, you should see the table for p-values, finding p-values. I know in the past it's taken a few minutes for it to go back on the whiteboard, but are you able to see it right now? All right, so what I did was I went ahead and I copied that diagram for finding p-values. So it should be popping up on your whiteboard. It's there. Okay. Thank you for letting me know. All right, so then the problem says find the p-value. And so when you're using the p-value method, the diagram that I'm following is the one that I just showed you. So the first question says, what type of test is it? It's either a left-tailed, right-tailed, or two-tailed. I think for this one it was the two-tailed, right? Then it asks, is the test statistic to the right or to the left of center? So is the test statistic positive or negative? So it looks like it's positive. So then we are looking at a right tail, 3.75. And the p-value is going to be the area in that times 2. So remember, it was a two-tailed, but this is symmetric. So if you know the area on one side, you can just multiply by 2 to get the area of both sides. All right, so if you did this by hand, you would be using this diagram. So the test statistic was to the right, so then that's how you find your p-value. It's twice the area of the right. It's equal to twice the area to the right of the test statistic. So once you find this area, you're going to multiply by 2. Now, in order to do this, we're going to have to use table A2. So if you're using the p-value method, the area that you're finding, that's your p-value. Before, with the critical value method, the area that's shaded, that was your alpha. But not here, not with the p-value method. The shaded area is your p-value. And then you compare that shaded area with alpha to see if you're going to reject or not. So you have your table. Table A2, you're going to look up 3.75, and that's going to find you the area to the left. So if you go back to your table A2, and you're going to look up 3.75, so here's the table, 3.75. Okay, well 3.75 is not here. So do you see what you would use? Now this is just the area to the left, and I believe we needed the area to the right. So the area to the left is 0.9999. So if you subtract it from 1, you're going to get the area to the right. Okay, so then from our table, 0.9999. So the p-value is 1 minus that. That's 0.0001. Now that p-value is from the table, and you'd need to tell me that that's from the table if you decide to use this method to find the p-value. So our p-value is 0.0001. Yes, that's our p-value. Now, the other thing you could do, so I'm putting an or here, is you can just use the z-test to find your p-value. If you do that, then you just have to tell me you used the z-test. So you used your calculator to find the p-value. So that would require that you type everything in. And I'm hoping I remember all this information. So n is 100, x bar is 40.6, standard deviation is 1.6. Okay. Okay, so here I'd go to Stat, over to Tests, and then I'm looking for the z-test. It's number 1, the z-test. Then I go ahead and press Enter. And I do not have data, but I do have stats. And I know I have stats because I was given a mean and a standard deviation. The value of the mean and the null hypothesis was 40. So we have to change that to 40. Sigma, which is the population standard deviation, that was 1.6. The mean of your sample, that was 40.6. Our sample size, I believe that was 100. And now we have to choose the inequality that was in our alternate hypothesis. And I believe in the alternate hypothesis, it was the not equal to symbol. So go over not equal to until it's flashing and then just press Enter. And then you just go over the word calculate and press Enter. All right, so look at the p-value. It's not the same as the p-value we got on the table. And the mistake that's usually made when you see this p-value is that students want to tell me this is 1.77. But a p-value is a probability. We can have a probability that's greater than 1. So if you tell me the p-value is 1.77, that is completely wrong. So you have to make sure you continue looking at your calculator. Notice that there's a part at the end. There's a little part at the end. It has e to the negative 4. So that 1.77 has 3 zeros in front of the 1. It's a very small p-value. So I'm going to write 3 zeros in front of the 1. So there's a decimal and then 3 zeros in front of the 1. Then I have the 1, 7, and that 8 makes the 6, 7. So you have to make sure you're looking at that p-value correctly. And so then you would just say that your p-value is 0.0001. That was supposed to be a 7. 0.0000177. All right, so that is rewriting it. So the calculator gives it to us in scientific notation, and you would write it. So that was 1.77 times 10 to the negative 4. That's what that was right there. Okay, so you can see that the p-values are not the same. So if you're using the z-test, your p-value is going to be different as if you use the table. So that's why you need to tell me what you did. I would accept either answer. So get comfortable with one of the two methods. When you use your calculator, it's much quicker. So I would suggest that whenever possible, you use your calculator. Unless a question tells you to use the formula, you'll use the formula. Otherwise, you're going to use your calculator. So it's very important to write down the commands. Was it a z-test, a t-test, a one-prop z-test? Whatever it was, you have to make sure you write down the calculator command. That is proof of what you did. Okay? All right, so that was our first question, our first set of questions from review number 1, 9 through 12. So go ahead and keep looking through those reviews and see what other questions you have. As I was going over this problem, I noticed that someone had typed out a question about notes. So okay, so the question referred back to the notes that I provided. So let me go back. And I wasn't trying to make this more confusing. I was just trying to be helpful, but I don't know if the opposite is true now. All right, so let me go ahead and show you. So the other question is just to confirm what I had said. So it says you'll be able to use this formula card. Write any additional information. It says, but keep it to 1 page. You can only have 1 page. Now, some of you, I guess, if you have a printer, might not print double-sided. So when you see this, when you open it up, it's actually 2 pages. It was intended to be 1 page back and front. So if you decide to use what I have provided here, you're only allowed to write in the front. You cannot write on the back because then you'd have 2 pages back and front. So you're only allowed to have 1 page of formula or notes, whatever you need to write on it. It just has to be 1 page back and front. So if you decide to use this one, then you can only write on the front. And again, I will have some of these available in case those instructions are not followed. I can't have one student have more notes than another student, so we all have to follow the same guideline. Okay? So if you decide to print out this formula card, which your printer doesn't do back-to-back, then you'll have 2 pages, but you can only write on the front side where you see the formulas. You can only write on the front side. And you don't have to use this if you prefer to just have your own page of notes and formulas. You can definitely do that. It's just 1 page front and back though. All right, so what other questions are there? So let me remind you, those of you who just logged on, I'm answering questions over the reviews that I had already posted. So I had already posted some reviews, and your homework last week was to have worked on these and bring me questions today. So there's no more new material this week. All right, so let me write down those questions. So we have a Chapter 9. So you just want to see any Chapter 9 example? Do you want to kind of look at that to see which one you would like to do? Otherwise, I'll just make one up. Okay, and then question 4 on review 1. All right, so let me go ahead and first do question 4 on review 1, and that way you'll have time to look at maybe some Chapter 9 problems you've been working on, whether it's on the review or something else, and we can do that. If you can't find any, then I'll just make one up. Okay, so question 4, review 1. So that'll be the next one. As a reminder, those of you who are watching the recording, you cannot participate because you're just watching a recording. You can't, it's not live for you, so you're just listening in. Okay, so here's review 1, and I'm looking at question 4. Okay, so Jesse, it just happens that this would be a Chapter 9 problem. this question 4 on review number 1. And the way you know it's a Chapter 9 problem is because you're dealing with 2 samples, so you're trying to make an inference or a generalization about 2 populations. So the information given to you tells you you have 2 samples, and that's, you see the N1 and the N2? Okay, so again, it just happens that this is a Chapter 9 question. So I'm going to copy that onto the whiteboard. All right, so the question was on number 4, but I need to do number 3 in order to get number 4. Researcher wishes to determine whether the salaries of professional nurses employed by private hospitals are higher than those of nurses employed by government-owned hospitals. She selects a sample of nurses from each type of hospital and calculates the mean and standard deviation of their salaries. So we have information for the private hospitals, and we also have information for the government hospitals. And so we have 2 samples. We have N1 and we have N2. So this has to be a Chapter 9 problem. So Chapter 9, just a summary of Chapter 9. We talked about P1 and P2. Those were our parameters, P1 and P2. Now, if you have to work with P1 and P2, that means that somewhere in the question you are given N1, N2. You're also given X1 and X2. Or maybe P hat 1 and P hat 2. So if you are trying to test a claim or construct a confidence interval on population proportions, then we're talking about P1 and P2. But that's not what we're doing here. Here, it's going to be mu1 and mu2 what we're looking at. And the reason for that is because not only does it say to find a confidence interval for the difference between 2 population means, which is mu1, mu2, but look at the information you're given. You are given the sample means for each. You're given a sample size and a sample standard deviation. Okay, so you're given sample means, a sample size, and sample standard deviations, which is everything you need to make predictions about the difference between 2 population means if you're constructing a confidence interval. The other thing we had with Chapter 9 was the mean difference. That's the other thing we had with Chapter 9. If our parameter was the mean difference, you were comparing that to 0. So in that, you were usually given data, and it was set up as a before and after. So for the mean difference, you were given data, and it had the setup where we had the before and the after situation. All right, so it's important to know what you have so you know what to do. So it's important to know what you have so that you know which formulas to use. So in this case, it tells us that we want to construct a confidence interval for the difference between the 2 population means. So confidence intervals, if we have 2 samples, that's Chapter 9. So when you go to your formulas, and that's the same page of formula cards that I made available to you, if you decide to use it, that's this one right here. All right, so it's a confidence interval question. So I have all the formulas here for confidence intervals. There they are. And it was the confidence interval for the difference between 2 population means. So we're looking at the second one. So if you're asked to use the formula, then you have the formula right here. But if the question doesn't specifically say to use the formula, you can use your calculator. Whenever possible, I would suggest you use your calculator. You just have to make sure you write down the commands. So in this case, I'm going to go ahead and use the formula so you know how it works. And only if in the final, if I tell you to use the formula, that's the only time you have to use the formula. If it's specifically, if those instructions are there for you to use the formula. All right, so I'm going to go ahead and copy that down. and we are going to use it. All right, so I'm back to the problem. That's what you should see on your screen. So we have the sample mean, the difference in your sample means minus the margin of error for the left side, and the difference in your sample means plus the margin of error, and that's on the right side. So you have information on the left and information on the right. All right, so that's your confidence interval. I just copied down the formula that we just looked at. Okay, so for the margin of error, just copying down the formula, it looks like this. It's the t-critical value times the square root of the standard deviation squared from your first group plus your standard deviation squared from the second group. And then you're just going to use this, for degrees of freedom, you're going to use the smaller of the two sample sizes. Okay, so making sure you have the right formula is helpful. All right, so what I'm going to do is I need to look up what this t-critical value is. That's what I need to do right now. So if it's a t, then you're looking at table A3. So if it's a t, it's table A3. And then my degrees of freedom is going to be using the smaller of the two samples, which is the 32. So it's 32 minus 1. So that gives me a 31 degrees of freedom. You need to make sure you're looking at the smaller of the two samples. That calculates your degrees of freedom. And so now just go ahead and look for table A3. Confidence intervals are always two tails. Remember that, confidence intervals are always two tails. Here we have a 95% confidence interval. So alpha is 1 minus 0.95, which is 0.05. So that is the area in two tails. You could also find the area in each tail, which would have been 0.025. But the way the table A3 is set up for you, it has area in one tail and area in two tails. So you don't actually have to have the area in one tail to use the table like we did in table A2. All right, so let's go to the table. Now remember, degrees of freedom is 31, and 0.05 is the area in two tails. Okay, so here we are. Area in two tails. This is the row I'm looking at, area in two tails. And I believe that was 0.05. And remember I said that makes the area in one tail 0.025. Okay, so that's the column I'm looking at, and I have to go down to 31 degrees of freedom. So remember, this is the column I'm paying attention to. And it looks like 31 degrees of freedom is right here. Okay, so 31 degrees of freedom is 2.040. So that's what I'm using. Now the rest we already have. It's given to us in the problem. The sample standard deviation squared times over its sample size plus the sample standard deviation squared divided by its sample size for the second group. So this information we already have here. So it's just a matter of plugging in. All right, so I'm going to bring up the calculator. So you basically, I wrote down the formula, and I found the t-critical value, and that's all you need to show me what you used. The rest you could still do on your calculator. So let me show you that. All right, so hopefully I have to write all this down so I don't miss it. So we have 32, 26,800. 600 for, that's the first group. The second group is 40, 25,400. One of my screens disappears when I go to the calculator, so I just want to make sure that I have all this written down. Okay, so taking you over to the calculator. All right, and here it is. I am going to type in, I'm trying to find the margin of error, right? So I type in the 2.040. That was our critical value times the square root. And remember, the first standard deviation was 600. I have to square it and then divide it by 32. And then to that I add the other standard deviation squared. And then I divide that by 40. All right, so that's what I get for the margin of error. Again, I have to take each of the standard deviations, square it, and then divide it by its sample size. And you can store this by using the STO button down here. Store it and do alpha E, so it just remembers that's what E is. That's our margin of error. All right, so the formula says you're going to, on one side, you're going to take the difference of the sample means. So it's x bar 1 minus x bar 2. So the first sample, I believe, was 26. The first sample mean was 26,800. And then I'm going to subtract the other sample mean, which is 25,400. Okay, so that was the difference in the sample means. And I'm going to subtract the margin of error. That is what was on the left side of my confidence interval. Okay, so that's the left part of my confidence interval. If I just do a second enter and change that minus to a plus, that then becomes the right part of my confidence interval. All right, so let me move that over to the other side and let me just show you real quick. So I stored the margin of error and I typed in the difference in my two sample means. Okay, so I showed the formula that I used, I showed the critical value, everything else was done on the calculator. So if I ask you to show me the formula you used, you want to make sure you write it just like I did right now. And then after that, again, I said the left side was 1139. And I'm rounding it to the nearest dollar. I don't think I said here how to round, but nearest dollar is fine. All right, so that's my left value and that's my right value. If you look at my screen here, I stored the margin of error so that I could later just type it in. So this is how I got the left part, and this is how I got the right part of my confidence interval. And that's just what I copied here. Okay, so this is using the formula. And so now the question that was asked was question 4. Is there a significant difference between the two groups? So the way that we determine whether or not there's a significant difference is if you is to see if 0 is included in the interval. So the first question you ask yourself is 0 included? Now, this is going to be the case for all of your Chapter 9 confidence intervals because it's not a confidence interval on the population parameter. It's a confidence interval between the difference of your population parameters. So we say no. Okay, good. No, 0 is not included because you go from one positive value to another positive value. And there's no way that 0 is included, right? from a positive to a positive 0 is not included. So that means that mu1 minus mu2 could never equal 0. That's not even a possibility. Mu1 minus mu2 could not equal 0. So that means mu1 and mu2 are not equal. So the question here says, is there a significant difference between the two groups? Right, so based on what I wrote here, are the two groups different? What do you think? Are the two groups different? So it's all based on what I just wrote here. I wrote mu1 not equal to mu2. So are the two groups different? Yes. So when it asks, is there a significant difference? You would say yes, there is a difference. There is a significant difference. The two parameters are different because there's no way the confidence interval includes 0. So there's no possible way that the two parameters could equal each other. So there is a difference. Does one hospital really pay more than the other? Well, one hospital does pay more than the other because the mean wages are not the same. They're different. Yes, there is a significant difference since 0 is not included. So you're going to answer the question and then you're going to explain why there is a difference or why there is no difference. So the explanation here is that 0 is not included in the confidence interval. So for all your Chapter 9 questions, you have to look to see if 0 is included in the confidence interval or not. Now, when you use the formula is going to get you a different confidence interval than the calculator, and that's okay. That's why you need to tell me how you got your answer. So here you could see that I did use the formula, and I did have this critical value, which, by the way, was a rounded value, so that's one thing that's going to make a difference. Now, I want to go ahead and do this problem a different way, and this way I'm going to use the calculator. So if you use your calculator, this would be the two-sample t-interval. Let me see on the formula sheet how it looks. Yeah, it's right here. It's the two-sample t-interval. So when we're doing a confidence interval for the difference between two population means, if you want to use your calculator, it's the two-sample t-interval. So then if that's what you used, then that's what you write. Two-sample t-interval. And let's go ahead and do that and see what happens. So if I don't specifically tell you to use the formula, this is what you would do. You'd go to your calculator, go to Stat, go over to Tests, and look for the two-sample t-interval. Now, the commands start for hypothesis testing, so you have to make sure you go all the way down until you find the one you're looking for. Two-sample t-interval. There it is. So we have stats because we have the mean and the standard deviation. We have stats, not data. And so then you just start entering the information. So the mean for the first group, I believe that was 26,800. The standard deviation was 600. The sample size is 32. And then we're looking at the second group. The sample mean was 25,400. The standard deviation is 450. And the sample size is 40. Now I believe the confidence level is 95%. So I'm going to leave that as 0.95. Now, it didn't say anything about the population standard deviations being equal. So our pooled is no. So the default is no. We are assuming that they're not equal. If it did say that the population standard deviations were assumed to be equal, then you would say yes to pooled. But in this case, it didn't mention anything, so I go with the default. So I say no to pooled. All right, now over the word calculate, I'm going to go ahead and press enter. And so, yes, the answers are a little bit different. So if you're using your calculator, you should be back on the whiteboard, by the way. If you're using your calculator, it should be 1,144. And then on the other side, it's 1,656. So if you were using your calculator, yes, your answer would be, your confidence interval would be different. But you would tell me that you used the calculator and you would write down the 2-sample t interval. And that would be enough, that you write down the calculator command that you use. That would be enough. Now, again, whenever possible, you're going to use your calculator, making sure you write down all your calculator commands. Only if I ask you to show the formula and to use the formula are you going to use the formula. The problem here is that you cannot possibly use the formula for all of these problems, because if you do, you're not going to have time to finish the exam. So I am going to pick and choose which problems you're going to show the formulas on. Again, you can't do it for all of them, as you just will not have enough time to finish the exam. So you need to make sure you are comfortable using your calculator. All right, so Ben, does that match what you have? Does my calculator answer match up with what you have? Okay, perfect. Okay, sounds good. All right, so there was a question about Chapter 9, so I don't know if this helps with that Chapter 9 question, or maybe you found a new Chapter 9 question you want to go over. If not, then I am going to do like a quick review as far as how you should approach the questions as you're going through the practice exams here. How you should look at the problems. So if there are any questions, please type them out. Okay, review 1. (30 to 36). All right, so let me move over. So this is our review 1, making sure I'm looking at the same one you are. So while you read these questions from chapters 7 through 11, in chapter 7 we went over confidence intervals, and chapter 8 we went over hypothesis testing. But both were for just one sample. So when you read the questions, that's the first thing you have to ask yourself, right? Am I doing a confidence interval question or a hypothesis testing question? And depending on your answer, well, that's what you match them up to. So if it happens to be a hypothesis testing question, then you know chapter 8 and chapter 9 or hypothesis testing questions. So make sure you have those formulas. The next question is do I have one sample or two? Am I looking at one population or two populations? So you have to break it down. You have to make sure you know what the question is asking so you can match it up with the right formula. Okay, so here's review number 1, and we're looking to 30 to 36. Okay. All right, so as you read these questions, the first thing you want to find out is, are you being asked to do a hypothesis test or a confidence interval? So is it a hypothesis test or a confidence interval? So for this one, it clearly tells you in the problem what you're supposed to do. It says test the claim. So you know it's hypothesis testing. That's your key word there, or your key phrase. So we did hypothesis testing in Chapter 8. We also did hypothesis testing in Chapter 9. Those are the two chapters we did hypothesis testing on. Now, Chapter 10 and 11, there was components of hypothesis testing as well, but the setup was a little bit different because we were looking at different things. So here, the parameters that we're looking at for Chapter 8, we had mu, we had sigma, and we had p. For Chapter 9, we had P1 and P2. So Chapter 9, we had two populations. We had mu1 and mu2. And we also had the mean difference because we were looking at before and after data. In Chapter 10, that's when we were looking at linear regression. So that our population parameter there was rho. So Chapter 10 was different because it talked about linear correlation coefficient. So we only did that in Chapter 10. And then the parameters for Chapter 11, we were testing for equal outcomes. So there are really no parameters. We were just phrases. We were testing for equal outcomes, which was the goodness of fit test. We were testing for independence. And we were testing for the means being equal for 3 or more populations. Okay, so this was, the first one was the goodness of fit test. The second one, so this was the chi-squared goodness of fit test. This was down here is just the chi-squared test. And then over here we used ANOVA. Okay, so Chapter 11 also had phrases about test the claim, but we had statements about equal outcomes or equal frequencies. We had statements about independence, about testing independence, and then we had statements about testing whether 3 or more means were the same. Okay, but all of these chapters had the phrase test the claim. So what you have to do is you have to decide which population parameter we're looking at so that you can match it up to the appropriate chapter. A medical researcher claims that less than 23% of U.S. adults are smokers. Okay, so here's the claim. That less than 23% of U.S. adults are smokers. In a random sample of 200 adults, so you know a random sample is your N. From the sample, we get 22.5% who say they are smokers. So if a percentage comes from that sample, does anybody remember what we call it? Okay, so it's p hat. Good. Okay. So if it comes from our sample, it's p hat. Percentage that comes from our sample is p hat. So that's 0.225. All right, so from around a sample of 200, 22.5% say they are smokers. Test the claim that the proportion of adults who smoke is less than 23%. All right, so we know it's a hypothesis testing question because it does say test the claim. The question here is, do you have just one sample or do you have two samples? So you have to decide whether you're in Chapter 8 or Chapter 9. So you have to be able to identify whether you have one sample or two. What do you see? Okay, so once you're able to identify how many samples you're looking at, then you should be in the right chapter. So we only had one sample of 200, so we must be in Chapter 8. Okay, so once you determine whether you have one sample or two samples, the next thing you should be looking at is which is the appropriate parameter. What parameter is used to identify the claim? P, right? Because it talks about proportions, right? So it talks about proportions. All right, so then P is the correct parameter, right? So you know what chapter it's coming from because it says hypothesis, because we're testing a claim. It's hypothesis testing. You know whether it's one sample or two, and you know which parameter we're looking at. So proportions, when we're looking at one sample, that's our P. All right, so we have the null, we have the alternate, so P equals 0.23, so 23%, turn it into a decimal. The claim says that we have less than 23%. That's what the claim says, that less than 23% of U.S. adults are smokers, because it has the statement of less than, it's going to go in the alternate. So if your statement does not have equality, then it goes in the alternate. If your statement does not have equality, it goes in the alternate. And that's where it went. Okay, the test statistics. So now I have to decide what test statistic would be appropriate here. All right, so I had already copied this down. I don't know where it left. Let me just delete this. All right, that was Chapter 9, and I believe this was Chapter 8 right here. All right, so this is our Chapter 8. All right, so here you can see what we use for when we're testing the population parameter P. All right, so we're going to use that one prop Z test, and there's a formula. And so I'm just copying that down. So you have to make sure you understand what chapter you're in, because that's, the formulas are set up by chapter. So if you can identify the chapter you're looking at, then you have a list of formulas to choose from. And then of course you should, from there you're going to understand what the parameter being tested is. Okay, so let me go back and just copying that formula down. So we have P hat minus P over the square root of PQ over N. PQ over N. Okay, so there is the formula. and you just plug everything in. So p hat was the percentage that was in our sample, which we always write as a decimal, 0.225. P is whatever's in the null hypothesis. We're always working under the assumption that the null hypothesis is true. So in the denominator we have P again. And then Q, does anybody remember what Q is? Okay, right, it's just the 1 minus P, right? Okay, so we have everything we need. All right, yeah, so Q is just 1 minus P. Q hat is 1 minus P hat if you had to use Q hat. Okay, so then it's just a matter of putting all this in your calculator. And that is your test statistic. All right, so maybe you can type that in and tell me what you got. It's a Z, so you round it to 2 places. All right, so some of you, if you want to use the calculator command, we don't have X here, do we? But we can find X. Remember the relationship between P hat, X, and N? We know that P hat is X over N. So if you wanted to find X, we would have to multiply P hat times N. That would give you X. Now, X is not always a whole number. And if it's not, the calculator will not take it. So if X happens to be something other than a whole number, if it has a decimal, then you're going to have to use a formula. All right, but did anybody use the formula? Did you get a value here? Okay, so Z, we rounded to 2 places, right? So negative 0.17. That rounds to negative 0.17, yes? Okay. So remember, it's our test statistic. It's a Z, so you're rounding it to 2 places. So Z is negative 0.17. Again, I used the formula. And if you would use your calculator, then you have to make sure you know what X equals. So 0.225, which is P hat times N, is 45. So it just happens that it's a nice whole number, and we can just go ahead and use our formula if you use our calculator. So if I use the calculator, it'd be the 1 prop Z test. All right, so if you use the 1 prop Z test, you would get your test statistic. And that should be negative 0.17. But you have to have the information to type in. Okay, the next part is to find the critical value. So you have to decide what table you'd be looking at. We have table A2, A3, and A4. So which table do you think you'd have to use here? Okay, good. You have a Z for the test statistic, so table A2 would be the right one. So we have to decide whether we have a left, a right, or a two-tailed test. Where do you go to see if we have a left, a right, or a two-tailed test? And that's what the alternate hypothesis tells us to the left. Okay, good. All right, so remember that when you're using a critical value in the traditional method of hypothesis testing, the shaded region is always your alpha. The shaded region is your alpha. So in this case, alpha is a significance level of 0.10. So going to table A2, you're looking for the area of 0.10 to see what critical value that ends up being. It's going to be negative because it's on the left. So again, table A2. I'm just trying to find my table here. All right, so on your screen you should see the table. And remember, my z is going to be negative. My critical value is going to be negative, so I'm looking at the negative z-score. 0.0, I think it was 0.10, right? Was it 0.10? The alpha. Yes, okay. I was going to go back, but okay, 0.10. So you just have to look for 0.10 in the body of your table. This is the body of your table. Wow, 0.10. It looks like this might be the closest one. 0.10. So the area of 0.10, it's not here, but 0.1003 is closer than 0.0985. And what z does that correspond to? Negative 1.28. All right, so that is the closest one. So again, you look to the left to get the first part of your z-score, and then you look up to get the next part. So it looks like negative 1.28. Negative 1.28. All right, so negative 1.28. That is our critical value coming from table A2. So what we're going to do is we're going to compare our test statistic with our critical value to see what we do with the null hypothesis. So here's our test statistic. Does it lie in the shaded region or in the unshaded region? Well, let's see, 0's in the middle. And negative 0.17 is probably closer to 0. So it's bigger than negative 1.28. So we do not reject the null hypothesis. Here we fail to reject. So notice that I skipped over the p-value because I just want to go through it and get a conclusion before that. So fail to reject, so it looks like A is my answer here. And so then the wording of your final conclusion is going to come from that table that we had already talked about. Remember that table? And remember that our claim was in the alternate hypothesis. That's one of the questions we are going to be asked. Right, so I'm just trying to get a conclusion here. So does the claim contain the condition of equality? Our claim was in the alternate hypothesis, so no, it did not contain equality. Do you reject the null? We definitely did not reject the null. we fail to reject the null. So there is not sufficient sample evidence to support the claim. That would be your conclusion. There is not sufficient sample evidence to support the claim. All right, and I ran out of room, but that would be exactly what I read. There is not sufficient sample evidence to support the claim that less than 23% of U.S. adults are smokers. Then you just copy down what the claim is. So I went through this process and I skipped the p-value because that way, just with the critical value and test statistic, I can come up with the result. And then I finish the problem. And once I'm done with that, then I'm going to go back and get the p-value. And the only reason I do that is that I don't get mixed up between the critical value and the p-value, because that's usually a place where students make mistakes. So now that I'm done, I'm going to go back and finish off the part on the p-value. Well, you're going to use your calculator. So I already showed you how to do that by hand. There is that diagram for finding p-values. You could also use the one-prop z-test. So some of you were already doing that. So let me move you over. All right, so I know I'm going to lose all this information. So if I ask you what it is, if you can just let me know what it was, because you probably already did it on your calculator. All right, so we are going to go, I'm going to clear all this just to get a clean space here. Go to Stat, over to Test, and it's the one-prop z-test. Now here you're asked for the value in the null hypothesis. I've already forgotten the value of the null hypothesis. I think it was 0.23. 0.23. And I believe x, we found x to be, I think it was 45. Now, how did I find x? I had to multiply p hat times n. So I multiplied 0.225 times 200 to get x. It wasn't given to us, so you have to figure it out. The relationship between p hat, x, and n is that p hat equals x over n. And I just said n was 200. The inequality in the alternate hypothesis was, I think it was less than. So that's the one I have to select. Just go over the blinking part and press enter. Over the word calculate, I'm going to go ahead and press enter. Hopefully I remembered everything correctly. And there is our test statistic, negative 0.16, which is rounds to negative 0.17. I remembered that part. And there's our p-value. Okay, so there's your p-value. So based on your p-value, what should we do to the null hypothesis? So the first question you ask yourself is your p-value less than alpha? Well, in this case, it's greater than alpha. Alpha was 0.10. So what happens to your null hypothesis? Do we get the same result or do we get a different result? All right, so that just confirms we get the same result. You're going to fail to reject the null hypothesis. And our conclusion doesn't change, it stays the same. All right, so when you read these questions, on the final, they're all going to be mixed up. There are all these different word problems. Now what I did on these is I set them up just because it's easier for me to grade, but not all of your hypothesis testing questions are going to be set up this way. You may agree that my setup kind of gives it away, right? So you don't even have to finish reading the question. You know that it's a hypothesis testing question because of my setup. I'm asking you to set it up, test statistic, critical value. I'm asking you all these steps. And I do this just because it's easy for me to find your work and to grade. But there could be some questions on the final where I'm not going to set it up for you. I'm just going to go ahead and write this part up here. I just would give you the word problem, and that's it. And you'd have to figure out what kind of problem it is. So while you're reading these word problems, again, the first question you have to ask yourself, is it a hypothesis testing question or is it a confidence interval question? Once you know which one you're dealing with, then ask yourself, is it 1 or 2 samples, which means 1 or 2 populations. And then after that, then you have to decide which parameter you're looking at. So these are the parameters from the different chapters. So I broke it up here on the side. These are all the different parameters from the different chapters. And then chapter 11, we didn't actually have parameters. We had statements about equal outcomes, independence, and well, mu1, mu2, mu3, that was the only parameter we had on our last section of chapter 11. All right, are there any other questions? So I have a question for you. So do you feel like you need more review, in which case we will meet again on Wednesday? Or do you feel like you're ready? I like the fact that you guys had questions prepared for me, because usually when I do these, no one has any questions, and that's because no one has looked at the reviews. So that's why at the beginning I mentioned that maybe Wednesday we didn't have to meet, but do you think it will be beneficial to meet one more time? What I don't want is I don't want to set up a meeting and then not have anybody show up. That's what I don't want. Do you guys want to vote? You still have questions? How many of you say yes? You want to meet on Wednesday? You want to have one more meeting? Okay, I'm not getting any responses. Is anybody out there? I just want to, really what I want is just, I want commitment is what I want. Commitment that you're going to show up if I am here. All right, so far just one. I'm sorry, no, nobody. So one red X, one person voted. Okay, so I have one commitment. And I'm going to print this out so I know who said they were going to be here. And then I'll send out an email. And the others, are you still there? Only 3 people listening? All right, so I at least have 2 commitments. Okay. All right, so then Wednesday I will be here and I will continue answering your questions. We at least have 2 commitments. Okay, so keep going through the review material, and I will talk to you at the next class meeting, which will be our last class meeting. All right, okay, we'll talk to you then, and I am going to print this out so I can see. Okay, so my list is printing out. There are no lecture problems for today. You don't have to worry about that. So just keep reviewing for your final exam. Remember that your final will only cover chapters 7 through 11. So keep working on that. You still have assignments that are due under homework and quizzes. No lecture assignments, but you do have homework and quiz that is due this week. And I'm sure you might have something due today. So check your assignments. Okay? All right, have a great day, and I'll talk to you next time.